looks like we're recording. So let's get started with functions in Python. So what is a function? A function can be thought of as a named and stored code block that runs only when it's called. Right? So typically this is a block of code that you'd otherwise have to repeat in your program multiple times, right? Say we didn't use a function for repeated code. What happens when you need to change a portion of that code block? You'd have to change it everywhere the code block appears, right? So let's look at a quick example of what I'm trying to say here. So let's get rid of all this. All right, so let's say we store the amount of money 3 items cost in pennies, right? So cost of toy equals, let's say 2000 pennies. And then I'm just going to copy this and create like two more, right? So let's say cost of apple is 200 and cost of chili is, let's say, 300, right? And then what I want to do is I want to tell the user each of these amounts in dollars, right? So convert the pennies to dollars. So what I would have to do is price of toy. Right? So before I do this, I'll have to create a variable saying cost of toy in dollars equals cost of toy divided by 100, right? And then in here, what I can do is I can say price of toy, dollar, then I can add the variable I just made, right? And if I run this, oh, I get an error because we can't concatenate a string with a float. So I'm going to put a comma instead. Okay? And there we go, right? So it calculated the amount in dollars and printed it out, right? So now what I want to do is I want to do the same thing for these two, right? So I have to repeat this for all three of these functions, right? So basically I have to do this, and then in here I change the variable name to apple, change it to apple, right? And this is just very annoying in general, right? Because I have to changing everything over and over again. Right? So for apple, I do this, and then for chili, right? So this was quite a lengthy process, but in the end, we have a program that prints out these three prices in dollars, right? Now, what we can do using functions is we can create blocks of code that help us do this function over and over again without having to write the same code again and again, right? Let's go back to our presentation and see how we can do that. So how do you define a function? So functions are declared using the define keyword followed by the function's name, then a parentheses, and then a colon, right? The code that defines the function is indented underneath the function declaration. So similar to how if you have an if statement after the colon, whatever you put in the indented portion comes under the if statement, right? In a similar way, when you define a function, everything underneath that in the indented format is part of that function, right? Now, function can also take parameters, which is called arguments. If and these can be defined within the parentheses of function declaration, right? These parameters can then be used within the function definition. So we'll just have a look at one of these functions. But here you can see an example of two very simple functions, right? So the one on the left basically prints out hello world every time it is called. And the one on the right takes a parameter called name and then prints out hello plus that name um, as the function, right? So let's go back to our example that we were just looking at and see how we can create a function over there, right? So let's get rid of all of this, right? And let's create a function with the def keyword, right? And then I'll call it print price in dollars, right? And we'll give it two parameters, right? The first one will be the actual cost in pennies, and the second argument will be the item, right? So the item for which we are printing out the price. Then we put a colon over here and we go to the next line. So as you can see, it got automatically indented, right? And now I can define the function, right? So what do we want to do? We want to print out the price in dollars of a particular item using its cost in pennies, right? So how we can do that is we'll simply write print and then we'll say price of, right? And then we have our item, right? So let me space this a little better. Okay. Price of this item, and then we can write is, then we take the cost in pennies and we divide it by 100, right? So this will be our function. Now, how do we use this function? Now what I can do is I can say print price in dollars and you'll see it shows up like a normal function, right? So you write print price in dollars. Then first you put the cost in pennies. So for the toy, it would be cost of toy. And the second will be the item, which is toy, right? And now if I run this function, as you can see, it uses the define function from above, right? And it prints out the price in dollars for this toy, right? Using the two parameters that we provided to the function, right? So now what we can do is we can call the same function for apples, right? For example, so cost of apple, comma, apple, right? And if I run this, you'll see it does the entire function again for apple, right? And then similarly, I can keep going and say cost of chili. And then over here, I can say chili, right? And if I run this, you can see now we have this, right? And how this is helpful is now, for example, let's say I find out that there's a mistake in the way I was calculating the cost of pennies, right? Let's say initially I'd written 101 accidentally, right? And this would give us the wrong answer, right? So now instead of correcting this mistake 3 times, I can just go here, correct it once, and have it work perfectly fine in all 3 cases, right? So this is why defining your own functions is always helpful when you expect a piece of code to be repeated again and again, right? So how does a function work, right? So let's see how this Python file is executed line by line, right? So first we have line number 1, 2, and 3, where we just declared 3 variables. So these 3 get stored in our memory, right? Then we go to line number 5, and in here we have our defined function, right? So at this point, it will simply ignore this function and just remember that this function exists, right? So it won't execute anything. It will just know that this function exists. Then it goes to line number 8, and here is the first time we call the function, right? So what happens is now we go back up to line number 5, and the value of the variable cost in pennies becomes cost of toy, which in our case is 2000, and the value of item becomes the string toy, right? And then it goes inside the function into line number 6 and performs this print statement, right? Using these two values that we just defined. Then similarly, it will go to line number 9, call the function again, right? And cost of apple uh, will now be the value of cost of pennies, right? And the apple string will be the value of the item variable, and it will run the function again, right? And similarly for line number 10. So everybody clear so far on how to create a function and how to use it?
So just to reiterate, you're saying the function, the definition part is a function, and then we just to bring it down here, and then it will create what you, the command you're giving it.
Yep. So the idea is that we have a piece of code that we want to repeat again and again in our entire code, right? So instead of writing it 3 times, what we've done is we've defined this piece of code as being this function, right? And then we just call it 3 times instead of having to write it out 3 times.
Okay. Please repeat on the mistake. How do you correct that?
Yeah. So let's say I made a mistake over here, right? Let's say I put 99 instead of 100. And then if we press run, we can see all 3 of these are wrong, right? Now, if we had written this wrong piece of code 3 times, I would have had to correct it 3 times, right? I would have had to change this 99 to 100 3 times. But in our case, since we only define this function once, we only have to correct this mistake once. And when we run it, it is completely fine for all 3 cases, right? So this just helps your code be a bit more robust.
Oh, okay. Thank you.
All right, so going back to our presentation. All right, so as we saw, we have our function name after define the def keyword, right? And then after the function name, we have parentheses, which can be empty if you don't want your function to have any arguments. But if you do want to provide some arguments to your function, you can define them within the parentheses, right? So some variables that you might need to be able to perform your function. So in our case, we had 2 parameters, which were the name of the item and the price of the item in pennies. Then we also saw how we can invoke a function, right? So we simply just write down the name of the function, and if it has arguments, we provide the arguments inside the parentheses, right? So in this example, we had created a function that's name was hello, and it took an argument of the item that you want to say hello to, right? So in our case, if we say hello and then in the parentheses world, we have hello world, right? And to have a look at the function really quickly, we go to the previous slide. So on the bottom right, you can see the function that they're talking about over there, right? So it is the hello function that takes the name parameter and simply prints out hello, comma, that name, right? So over here, you see we can call it just by saying hello, and then in the parentheses, we can provide the argument. So if you do not provide correct parentheses, right? So for example, a function takes parameters, but you do not provide any parameters to it, you will get an error message, or as you can see on the bottom left over here, right? So be sure to call your functions in the same way you define them, right? So a little bit more about parameters. Parameters are essentially inputs to a function that are used within a function. So in our case, if we were to convert the price of pennies to a dollar, we do need the price in pennies, and we also need the item name if we want to print it out, right? So the order matters, right? So if you have made two arguments, that was our case, right? You have to put the arguments in the exact same order in order for your function to recognize them in that order, right? So as you can see, if we create a simple function to do exponentiation, which is to take a number and put it to the power of another number, as you can see, if we do 5 comma 2, we get 5 to the power of 2 equals 25, right? Because that's how the function is defined. The first number is the base and second number is the power. So if you do 2 comma 5, you will not get the same answer because the order of the positional arguments is changed now. Parameters are also named, right? So repeated names are not allowed. So if you try to define two of the same arguments, that will not work because you need two different variable names within the function to be able to differentiate between the two, right? So instead of invoking with positional arguments, you can also use keyword arguments, right? So let's have a quick look at that. So as we saw here, our first argument was cost in pennies, and our second argument was item, right? That is why we put it in that same order. But what we can also do is, let's say print price in dollars. Let's say we want a new item. Let's make another cost of, let's say banana, right? Equals 100. So now we look cost of banana. Sorry. So what we can do is we can change the order of the arguments if we use these variable names to define them, right? So what I can do is I can say item equals and then banana, and I can put a comma here and say cost in pennies, and I can say cost of banana, right? And if I run this, as you can see, this will also work. So you can change the order if you use the names of the variables you defined within the function in your calling of the function, right? But in most cases, you would want to do it like this because it retains the order and causes less confusion. This way, it will be a little more confusing. So I would recommend using the normal method, but this is something that Python also allows you. All right. Any questions so far? Okay. So parameters can have default values. So what you can do is you can also make certain arguments optional and certain arguments necessary. So using our example, let's have a look at this. So let's say that if the user of this function print price in dollars does not provide us the name of the item, we simply default the value of item to item, right? Let's say that's how we want to define it. So now if I use print price in dollars and say cost of banana and do not provide a second argument and try to run this, as you can see, it defaults the second argument to the default argument we defined here, right? So basically what this allows you to do is that you can basically have two definitions, right? One where you only provide the cost in pennies, and the second argument is defaulted to item, or you can still provide it the value for this variable. Right? And you can provide this default value to cost of pennies as well, but that probably wouldn't make sense in our case, right? See, all right. Any questions so far? So if a parameter is given a default value, it becomes optional when invoking the function. So you can, in that way, you can both have a function without arguments and with arguments in the same definitions. You don't need to define it twice, right? So in this first case, we can see we did not provide the argument in the parentheses, right? And it printed out world for us because in the above definition, we have set the default value as world. But we can still pass it an argument if we want to and override that default value of world with David in this case, right? If creating a function, both required and optional parameters, define required parameters first, optional parameters last, right? So you can't have an optional parameter first and then define a parameter that does not have a default value, right? So we can see an example of this really quickly. So let's say I get rid of the default value of item, right? And then I give the cost in pennies a default value of, let's say, 200, right? If I try to run this, it will throw me an error, right? Non-default argument follows default argument. So this is not allowed, and you will always have to define your uh, non-optional arguments first and your optional arguments last. Right. So as you can see in this example, that's exactly what we were talking about, right? So you will always have to provide the non-optional argument first and the optional argument last. Then we have the return statement. So as mentioned earlier, all functions return data to the caller. So right now, all our function was doing was it was doing a print statement and providing output to the user in the form of a print statement, right? But what we can also do is we can return a value to a variable within the code using a function, right? So let's have a look at this. So I'll get rid of all of this. And let's create a very simple function that simply creates a sum of three, right? And what this function will do is it takes in three variables. Let's call them x, y, and z, right? And it simply returns the value of the sum of these three, right? So let's create a fourth variable called w, and we'll add everything up. Right? And then what we do is we can use the return keyword to return this value, right? And let's have a look at how we can use this, right? So outside of this defined function, now what I'm going to do is I'm going to create a new variable, call it a, and say a equals sum of three. And then inside I can provide three numbers, right? So let's say 1, 2, 3. Now what will happen here is a will store the value that this function returns. So in our case, w, right? Which will be the sum of all three of the numbers that we provide. So let's say I print this A out. Now, if I run this piece of code, oops. All right, so as you can see, we get 6, which is the sum of all three of these, right? And this gets stored in the variable A using this return statement, right? So whatever values after the return statement gets sent to this variable, right? And what you can also do is, instead of storing it in a variable, you could use it directly in a print statement as well, right? So you can say print sum of 3, and this is completely fine. If I do this, I still get the same answer, right? So everything clear so far? All right. So functions with a return statement return the value specified after the return keyword, which can be stored in a variable, right? So in the example we have over here, we store it in a variable called user greeting, right? And then we can see that that variable gets the value that was returned by this function, right? So get user greeting is our defined function, right? And then inside we have a bunch of, we have an if statement that checks if a greeting is in a certain list, and if it is, it returns the greeting back. Otherwise, none is returned, right? So in this example, you can see that user greeting does not reach a return statement when using the function, which is why it gets a value of none. So let's look at an example of that. So let's say that in this function that we had defined, if w is less than 10, we only then we return w, right? So in this first case, we'll still get our 6, right? But if we do print sum of 3, and then we do something that will definitely be larger than 10. So the sum of 3 5s will be 15. As you can see, we get the answer none, because this if statement is not true and the return statement is never reached, right? So if you do not reach a return statement, you get the value of none. You can return multiple values with a single return by separating return values with a comma, right? So what you can do is you can simply, so let's have a look at our example again. Let's say I don't just want to return the sum. Let's change this function to also include multiplication, right? So our sum is this, and our multiply is x times y times z, right? So what we can do is we can do return sum, and we can also put a comma and say mul, right? So we can return two variables, right? So let's say we have sum of 3, right? Let's make this a variable, and then we'll call our function, right? And we'll actually define two variables. So the other one will be mult of 3. And then in here, we can provide three numbers, right? So 3, comma 4, comma 5, let's say. And then I can print out these individual variables, right? So if I run this, as you can see, sum of 3 gets these value of the sum stored, and mult of 3 gets the value of the multiplier stored, right? So in this way, you can return multiple values from a function. All right, so this will be returned in the form of a tuple actually, but we can unpack it using multiple variables, which is what we just saw, right? So if we define two variables to get those two values, we can unpack the tuple, but if you only have one variable, it gets stored as a tuple. So let's have a look at that as well. All right, so in this example, let's do the one variable way, in which we say sum and mult of 3, right? Let's make this a variable, and we'll say sum and mult of 3. And then again, let's use the same numbers, right? Now let's try to print out this variable. As we can see, it gets stored as a tuple, right? But if we use multiple variables, then it will unpack it and give them the individual values instead of giving us a tuple, right? All right, so documentation strings, right? So documentation strings, or doc strings for short, are essentially comments used to document a function's usage, right? So when I create a function, I always want to document it so that I can come back to it and see what I created this function for. And how you can do that is simply by putting 3 double quotation marks and pressing enter, and it will automatically give you a template for your definition, right? So in the first line, you would write what the function is doing. So in our case, we would say summing up and multiplying the provided values, right? So parameter x will be first value. This will be our second value. This is our third value. And we are returning the sum and multiplication result of the 3 values, right? So this is how you can document your function. And when you just come back to your function, you can quickly just read this instead of going through your function and trying to figure out what it's trying to do, right? So this is just something that helps you keep your code a little bit neater. And I would recommend you put a doc string on every function you create if possible. So everyone kind of has their own way of documenting it, but the default template that PyCharm gives you is kind of nice. So you can also use this doc string, right, as a variable and actually get it back, right? So let's have a look at that. So what I can do is, let's get rid of all of this. I can print out the doc string. Right? So I say sum and multiple of 3. Then I get rid of these parentheses and say dot doc. Right? If I print this out, as we can see, we get our doc string, right? So this is what we had written over here. And this can be one of the ways in which you can try to get doc strings of um, functions that are defined within Python, right? So let's have a look at the print functions doc string. So as you can see, the creator of the original print function actually wrote a drawstring, and it provides you with information about how you can use the print statement, right? So in this way, you can kind of go through a lot of doc strings and just try to figure out what different functions are trying to do, right? Functions to build a greeting to a user using, so this is the doc string we saw in the previous example over here, right? If we print it out, we can get the entire doc string. So let's leave scope for the next lecture, since I believe it is a longer topic and I don't want to touch on it right now. So we'll continue this in the next lecture. But are there any doubts in functions?
I think for me, I'll just have to go through the lecture again to get things, which is normal. So yeah,
Okay,
thanks. Though.
no problem. Yeah, I would again, once again, recommend you try to just write functions for yourself and try to get familiar with how you can define your own functions.
Hello.
Yep, I can hear you.
Okay, I just wanted to say that I still haven't gotten feedback on my on assignment 1 and assignment 2.
Okay, I'll work on that with the teaching assistant and get right back to you on that. That should have happened by now.
All right, thank you.
All right, so that's all I have for today. I wanted to cover scope, but that will take at least 30 to 40 minutes. And since we don't have that time today, I'm going to end the lecture here, give you back a few minutes. If there are any doubts, please feel free to hang back, but otherwise you're good to go. I'll stop recording.